So welcome to the developers meeting on Sunday, the 23rd October 22. And we are now going to see the shared screen of Mike, and he's going to show us his last experiences with CUDA and ROS2 and CPU variances.
Okay. So I'd like to just start by saying that I've got some instructions. They're all in the various repositories, so none of the stuff is off the cuff. So it's all written up and available for everyone to use and to try. And so I kind of just want to get that across there. So okay, so the first thing I would like to show, and the difficulty with this stuff sometimes is like doing a top down or bottom up sort of thing. So I think the first thing I'd like to show is I've got is running. So we currently have two projects in source control for this. One is essentially the main part of the simple tracker, and the other part is just a simple UI component. And I kind of want to demo the interaction between the one and the other, whereas the main engine part of Simple Tracker is running as a container. So I've got a container running here. I have all I've done is I've basically run setup and sourced it, and I can show you this part, the nanobit. So this is just simple setup, and it just takes a little bit of time. So that's just why I did it before. So the bit that I'd like to show now is so basically over here is I've commented out the visualizer node. So there isn't any UI that is going to be coming from this container. It does, you can probably see it runs several other nodes, but from a UI standpoint, there's nothing is going to be shown from this container. Okay, so
Mike, are you showing us something?
yeah.
Because we only see the Chrome, Firefox.
Oh, yeah, I am. Sorry. Yeah, sorry. Sorry, mate. Yeah, I want to show
You
you the whole
shared
thing.
the window, not the
Oh,
desktop. You have to share the desktop.
yeah, sorry. My bad.
No
My
worries.
bad.
Unshare and share again.
Is that
Oh,
better?
okay.
Can you
Yes.
see a terminal? Okay, sorry. Yeah, I apologize for that. So yeah, yeah. So okay. So all the instructions that I'm going to be using are essentially in the repositories. So this is basically Linux terminal, and I have the I've started the container using that command, and I've run setup, and I've sourced the the bash
RC.
RC file, and that is just purely I've done that just to make it quicker because it takes a little while to run. So so I would like to just show you the so this is essentially a launch file, and what I would like to show you here is these are nodes. Um, these are nodes, and the main bit that I want to show you is the fact that this is the UI node, which I've completely commented out. Okay, so the bit that I want to say is that no UI will be coming from this container. This is purely just basically it's going to just doing most of the processing. So just get that running quickly. Okay, so that's running now. So now what I want to do, so basically this is the UI project that I was referring to, and what we have here is the simple UI node. I'm going to run it, and then we can kind of dig into it more as you guys want to. So again, all I've done here is I've run the setup bash script. Okay, so and things might go wrong as well, so just bear with me. So basically what we're doing now is we're just building, and it has its own little launch file, so which should launch. Okay, so this visual is all it's doing is just showing a frame that is being retrieved from this container over here. Okay, so this is subscribing to a topic, which basically it's putting together the annotated frame, and that's the only thing it's showing. It's not doing any of the drawing of the rectangles or the tracking or any of that. So it's purely just showing this. And the reason I kind of wanted to show this is because I wanted to show that it's how easy it is to run run the main engine part of Simple Tracker, the ROS version, in a container, and then interacting with that container from a dev environment. Okay, so that's kind of the main.
So you have 2 ROS nodes right now, is it right?
No, there's several. So if you look over here, you'll see there's. So no, there's several. I think there are about 10 or 12. Yeah, the big thing here is just the big thing that I wanted to show is the fact that it's and the performance is a bit sucky at the moment. It ran better earlier, but the main thing I just want to show here is that it's easy to run a project that is using a development container and having that interacting with another container that's running separately. That's the main takeaway from this. Okay, so I kind of that's the main demo there. So I'm going to stop this now, and I'm going to run all of this in one project in one container versus the separation, because then we can go through it a little bit more in a bit more detail. Okay, so I just want to exit out of this container because we don't need it anymore now, so done with that. Right, this one, I want that one. Okay, so this is, the stuff that you saw running in that other container is this project, and each one of these things is a node. So 1, 2, 3, 4, 5, 8, 9, 10, 11, 12. So they're quite a few of them, and I'm just going to run this again. So just to baseline, and then we can kind of go from there. So okay, ignore that frame count. It's not right. That frames per second thing. So yeah, so this is now just running as a single project, like I guess in the development container. Okay, and this is just purely CPU. And I'll switch it over to using GPU in a bit, and then so this, anyone can run this. So all they have to do is basically go to the Docker repository, and these essentially are the instructions to run this, and it works on Windows as well. I can show you if you need me to. But the main thing is I kind of want to demo, the fact that it's tracking, the fact that it's running across several nodes. And then, yeah. So,
Mike,
okay,
sorry, just for explanation. The difference between the prior one and the one that is running now. Can you go back what the difference is?
yeah. So this is entirely ROS based. So, okay, So I don't quite know how to demonstrate that. The only thing I can try and do is if I do.
You can try to run RQT.
Yeah, I don't think it works on you, mate. To be fair, so That's not been part of my demo prep, so I don't want to try that because it will.
No, it should get you to everything that runs under ROS. It will show you. It will be fine. That's the debugging tool.
If I.
Would he have to install something, Ido, or is it running in a browser?
To install it, it's coming with ROS 2.
Okay, so you already have it, Mike, don't you?
I don't. I've never tried to use it, so I will.
Just
I've
run
not quite
RQT, enter.
So do I run that from the development Docker container or from my main machine? Because I don't actually have ROS. I don't actually have ROS installed on my main machine. So I had to recently redo the machine purely because my drive went. So I don't have ROS installed on the OS. This is purely just from a dev OS.
Got it. Okay.
So if I do this, so basically, what I'm doing here is, so I'll run it up and then. So I'm not terribly good at explaining stuff. So you guys just ask away if there's anything that you want a better understanding of. But essentially, here we have a whole bunch of stuff subscribing. So I've now enabled. So basically, what we have is we have topics being published to, and the visualizer component subscribes to endpoints that don't exist. And as part of a launch file, you can remap the endpoints that are published to and that the visualizer is subscribing to ensure that they line up. And that's basically how you enable and disable screens, essentially, is my understanding with ROS. So over here, for example, sorry, I just want to show. Yeah, so here we've got dense optical flow running. So all of this stuff, so basically each one of these things is running in its separate node. So dense optical flow is running in a separate node, which means it's its own process. So you actually have quite good scalability because each node runs its own process. So you get a lot more hardware utilization from a compute standpoint. So the only reason, yeah.
You can try, Mike, you can try from the container run ROS2 space node space list. Nodes list.
Yeah, that I can do.
I was going to ask a question. Is there buffering between these nodes? In other words, is the overall system latency higher than a frame?
That's what we will optimize for. Probably now it's not optimized.
No, it's not.
That's something we can have highly optimized.
Yeah, so those are all the nodes. So
yeah.
So one thing I want to do. So I just want to stop all these windows running and just basically get just back to the annotated frame. So because I kind of want to show you guys some other stuff as well. So if you just give me.
Maybe you can show Matt the subscription that you have, like the time-based, the real-time constraints.
So I don't. Sorry, I don't quite know the what.
So when you do subscription, remember, or publishing, you have the time constraints that ROS2 allows you to do?
Yeah, so I don't have any QoS defined on any of that sort of stuff at the moment.
Okay, okay.
So yeah. So basically, I've got. I can show you. So if I go to the annotated frame provider, so this is the thing that basically creates the frame that's for display. So I can kind of get into this if you guys want me to, but basically I've got several node subclasses. So I've got let me show you, I'll show you the config one. I'm just trying to figure out. Yeah, so I've got a configured node, which is my base class, and then I've got a control loop node, which so essentially none of the messages being received don't kick off the processing. The messages being received are just stored in the node, and then there's a control loop that runs at 10 hertz on every node that does the main processing. The reason for that is I don't want to kind of clog the queue as the messages come in. I don't want that to be the
So you don't need that. You want to rely on ROS2 to do that
yeah.
for you.
So the book I'm reading has a different view.
No, I don't know what the different views, okay? But ROS2 is your system of service, okay? So that's the runtime platform that needs to manage all of it. If you mess around and you create your own loops and control in the middle, you interfere with the overall real-time system in the end.
Yeah, I mean that's a fair. I'm not gonna argue with you on that because I honestly just don't know. I've just basically just going through a book and just trying to learn from that really and kind of do what they suggest. But so basically I've got this thing called a configured node, which allows all nodes to subscribe to configuration, and what that does is it allows me to kind of do stuff like this. So I can, so you can, I don't know if you can see, there's some processing happening in the background here.
Are you reading a ROS1 book or ROS2?
No, it's a ROS2 book.
Okay, because that stuff that you speak of, it's like around ROS1.
Yeah. So
Okay,
yeah.
Go for it. It's fine. We will get there anyway. So.
Yeah, no, that's fine. So basically, I can zoom in quite easily and I can zoom out quite easily. So this is kind of, there's quite a lot going on here, as you can see by all the stuff going on in the background. It's essentially writing to the notifying the configuration node that there's a configuration change, and that then makes a change and broadcasts to other nodes that are interested in that configuration change to say this has changed, reload your node's configuration and continue processing. And that's kind of all, that process is happening with each one of these sort of keystrokes. And the other thing that I can show as well is like if I, so this is dynamically applying a different mask, and you can see it's like throwing up the background subtractor quite a bit because it's learning process. So and then we go back to the old mask, and then the other thing I wanted to show was I've made it so that I can switch controllers even. So I've got a controller that is for my camera outside.
Mm-hmm.
So this is basically my camera outside, well,
Okay, you
tracking
just
rain
switched it
droplets.
now. How did you switch now?
That's part of the stuff that I've got glued in with all this configuration stuff.
Okay.
So you're changing from a simulated environment to a real environment. That's nice.
Yeah, well, I think it's quite neat, but yeah, I mean, it's just me. But yeah, Yeah, the fact that you can go from, I can switch from one to the other, and it's quite a big thing, right? Because it's not, as you can imagine, all these nodes run separately and in separate processes. So, there's a lot of processing that goes on when you do that, because frame sizes are different and masks have to reload, and all this sort of stuff. So there's quite a bit, of involvement happening when I do that sort of thing. Really, I mean, this is one of the things that didn't work when I was trying the CUDA version, but we can give it a go in a bit. But so yeah, so that's
I do have a question.
sure.
Where are you getting the video from in your code?
So yeah, okay. So basically, right. So I have a camera node that has a videos folder that is being included in the build process, and if I go to the camera node, this is, that's my control loop, and then if I go to so this is my controller. So basically, at the point of the configuration broadcast happens, if this node is interested in any of these configuration topics, it basically reloads its configuration. So this is the initial config bit, which doesn't have to reload, but it'll reload this. So it's this controller element. So the controller, there are a couple. So we've got a camera controller and we've got a video controller. And the video controller is the thing that depending on what's configured, it'll read the video file from disk and open it and play it. And then if so if it's configured to play in a loop, it'll just keep on looping over. So it just continuously plays the video. But this is not where you would get a video feed from. So basically, this is essentially like a camera mock. So I then have something called a frame provider, which is my entry point of processing. And over here, so in the shared folder, I've got something called a frame processor, where I've tried to abstract basically implementation. So over here, I've got a GPU implementation as well as a CPU implementation. And this is just the base. So in the frame provider node, so the frame provider node is essentially the starting point for Simple Tracker. The camera node will be definitely replaced at some point, but the frame provider node will, as part of the control loop, it'll process the frame for the frame provider, and basically that depends on if you in a CPU based environment or a GPU based environment. So if you're in a CPU based environment, it does CPU based stuff, and this will also be where it applies the mask. It does the blurring, it does those sorts of things. And if you in a GPU based environment, it does the same thing, but here we have to basically upload the frame to GPU and then apply the mask and stuff there. But it's to try and abstract away the fact that we support both CPU and GPU. Simple Tracker did this as well, in all fairness. So a lot of this is just copying and pasting from there. But yeah, it's just to demonstrate that there is a frame processor that is two implementations, one being CPU and one being GPU.
Let's say that I wanted to use a random video that I have saved on my laptop. Where would I put that? Where would I put the name of the video?
Okay, so you would you would include it in this folder.
Mhm.
So you would, okay. So you'd probably have to map a volume. So basically you would end up running the container for this with a mapped volume that you can then feed videos into, I would have thought. Otherwise, just let me know and I can include it in the image if it's less than 100
Okay.
meg in size.
Okay.
I mean,
I,
that's probably going to be easier, really.
Mike,
Thank
I
you.
have a question. Can you hear me?
Yeah, sure.
Yeah. You can hear me. So this is Lionel from Belgium.
Oh,
We
hi,
spoke before. Hi.
Hey, Lionel.
So I heard there were topics which you subscribe to. Is that same model reused once a frame or a sequence of frame gets annotated? I mean, if I subscribe to, let's say there's a topic for annotated frames, and I subscribe to that, will I get a string of coordinates, or will I just get a single coordinates with a GUID?
So no, so every node runs at 10 hertz. So you should get 10 publishes to the topic per second.
No, okay. Let me explain something. The hertz, the publisher can decide how fast it want to be, but it's up to the subscriber to decide the rates it want to see. So you can subscribe to 1 hertz changes, and you can subscribe to 20 hertz changes.
Yeah, so I've
Okay.
not quite got that far. So
Okay.
yeah. So I'm not quite there
Bear in
yet.
mind, that's how the written system will be determined in the end, and that's how ROS 2 will optimize everything, because it's looking at the subscription time requirements.
And but what about the data model? Is it once you get a track, is it a string of coordinates, or is it a single coordinate for this particular frame? String of annotations.
So I have to cope with that so I have to kind of deal with this in the annotated frame builder. So essentially what this does is this gets all the tracks. So as part of the track, so the topic that you subscribe to get the tracks, as part of that message, you will get the frame as well. Okay, and then what I do is what I do is I get the frame, and over here you can see I get the frame, and then I also loop through the tracks to then draw the bounding boxes, and then I've also got this little bit that puts that inlay, that zoom, that little thingy that zooms in a little bit. And then so I do all of that, and then I publish the annotated frame onto a topic, and then that visualizer thing that you saw, the main like graphical element of the application, that just subscribes to the annotated frame topic over here.
So maybe getting back to the question, is it more that do we have access to the trajectory or the track history? So maybe there could be a node which is the track recorder.
So currently, so just also bear in mind, right? I'm self-taught. I heard about ROS a month ago or month and a half ago. So a lot of this stuff is very much. This whole project is just me kind of trying to figure stuff out as well. But so it could very easily be I'm doing the wrong thing. But so one thing I do have is like a historical path, and I need that because if I show you, so I do have a track history, and I do also actually have the state of the track history, and I'll kind of once this thing comes up, and I'll explain what that means. So if you have a look at this now, so you'll see it draws a bounding box around an object that's identified for tracking, and then it'll also draw a path of that the object took that it's tracking, and it's just getting overwhelmed there by all the golf balls or tennis balls. So if it picks it up on this side again. So
on écoute la même chose.
Oh, it lost track. Is that what happened?
Yeah, so it lost track there, and so now it's tracking again, and you can see that entire trajectory line is something that is published. So that's basically the historical trajectory line, and that's not state that is stored in that node. That's state that is. So the annotated frame provider gets that on every topic published, so it can draw that line. So on every frame refresh, it draws that entire line from the beginning to the end. So there is the trajectory path is published, if that makes sense.
Yeah. So another thing about subscription to events in ROS2, when you subscribe to event, besides specifying the hertz that you want, like how many, how often you want to get that, you can also define how much history you want to get with each event.
So,
that's being done automatically for you. Yeah.
Yeah. So I could probably do with some help in that area, really. So if you want to have a stab at having a look at the code and seeing, and maybe making some suggestions, I'd be really kind of keen on that. This is just stuff, as I say, that I've put together just because I just trying to move it forward, really. So I guess the point I'm trying to make is that, like, all of these tracks and all of the historical, the historical path that has been tracked is all published every time. So you don't necessarily have the frame of where the object was before, but you have the path it has taken. And that all comes through on the track. I think it's the track node or something. It's the tracks topic. So that comes through.
Mike, how about if you create like a GitHub issue around this, and then we can discuss it over the GitHub issue.
Yeah, no, that's fine. See, the thing is, the difficulty I have is I don't necessarily know that it's an issue, right? Because I don't know ROS well enough to know what is an issue and what isn't an issue.
It's not an issue, but let's get a discussion around the subscription, okay? And I can gather some samples for you, so you understand better how to do the subscription and how to manage the history, because you don't really need to write any code to manage the history. It's being delivered by the ROS2 system.
Okay.
Okay.
Okay. So that was kind of. Let me just go have a look at my script quickly, so that I'm going to.
May I throw a question in it, Mike? Sorry.
Yeah, of course.
Ido, you mentioned something. Does that mean what you said, that ROS2, the system as it is, already is buffering? You can say what it is storing, and then you just call it, let's say.
Yeah. So you need.
Je suis là pour aller me garer. Ok, t'as trouvé une place? Non, mais je vais me retrouver. Non, je remplis la cour.
Let me see
Lionel,
if I can find.
can you mute, please?
Sorry, I'm
It's
the
okay.
middle of I'm moving my apartment just now. But okay, I'll mute. Sorry about that.
No problem. No
it's
worries.
great stuff.
No, so I'm just going to quickly just swap out a video for something else, really. So And then I can show you I can show you guys the CUDA stuff. So now it's just showing a different video that you're probably more kind of familiar with, I guess, because this was in Simple Tracker as well. So this is kind of the main video for Simple Tracker. And then I can show you the CUDA bit if you want me to. But the CUDA, so the difficulty we currently have is the background subtractor we have in CUDA is not as good as the background subtractor we have for CPU. So I can show you the background subtractor and how it performs in CUDA, and I know that's something Fabio is gonna at some point look into is seeing if we can, so essentially we want to do testing on background subtractors, and then the one that works best we want to convert to CUDA as well. So that's ultimately the kind of goal, really.
And what background subtractor are you using right now?
So this is one of the ones from the BGS library. It's the weighted moving average. I've kind of found it to be the better one. Very much so.
You tested 5 already, did you?
I haven't. No, I haven't, because it's no. We haven't. We haven't quite got there yet.
Okay.
In all fairness, so.
But
if
the
I
plan to test it also true?
Oh yeah,
Okay,
absolutely.
okay.
Yeah. No, definitely. I can't wait to give it a go. But I just got to kind of include it in the build image, and stuff. So I got to get it compiled, and then include it in the build image, and then I can give it a go. So if I just have a look at the CUDA one here, so essentially what we've got here is we have so we've got CUDA enabled for the frame provider. We've got CUDA enabled for I think it's the dense optical flow, and then the background subtractor, and we use the MOG2 CUDA option, because the only options we have is MOG and MOG2 for CUDA currently in OpenCV. But the cool thing with using ROS2 is, so because those are independent processes, I can enable CUDA for some stuff, and I can, because that one, did I change? Oh, I did, yeah. So we, we can still kind of mix and match a little bit, but.
So this is now running in CUDA. MOG2
yes,
on CUDA.
So MOG2, yes,
okay.
yes.
Just from your configuration, what is your impression? The CPU is better than the CUDA?
Yeah, it's just crashed there, I think. So performance-wise, like the performance throughput on old Simple Tracker is a heck of a lot better with CUDA than with non-CUDA, because it's a single process. So basically, you get all your stuff up into CUDA, and then you can process it there for longer. Whereas with this, it's slightly different. And I know there's the nitros thing, which I need to look at. So that's something's died. So sorry, yeah, that's a quite. What's that?
You're talking about the performance trade-off of running this all in one process versus having it in separate nodes where you're putting it in and out of GPU memory, for example.
Yeah, exactly that. I know there's something called nitros or something like that, which I've not explored yet, but
I would just not to worry too much about that because there is a natural progression where you start with very finely grained modules, and you're prototyping and you're figuring out what works. And when you figured out what works, then you put it in one process, right? You're optimized for flexibility now and performance in the future. I mean, that's both natural and expected anytime you are building this kind of stuff, right?
Okay. Yeah. No, that's fair enough. I mean, I was getting basically about 3 times the speed with like a single process, the simple tracker thing using CUDA versus using GPU, whereas it's different, yeah. But
Right. And ultimately, you guys will figure out the factorization that makes sense. And maybe you'll aggregate more functionality in one node to take advantage of that. Right.
I hope so. Yeah.
I think
We're working towards it.
right. Well, it's a trade-off where right now you have a lot of uncertainty about what you're going to build and how you're going to build it. So the most important thing to you right now is flexibility and ease of bring up and, the ability to try different stuff. So
Yeah.
I think the progression makes perfect sense from that standpoint. As long as you keep in mind, you can always aggregate nodes later.
Yeah, that's a fair point. Yeah. So you can kind of see thanks for that. The Mark II thing, I'm not a big fan of.
No.
It's very, yeah. So, well, what we can do we can go back here, and because that's sucky, we can basically swap that out. So that's false. And now
what we add that to your configuration later.
Yeah, so now what we can do is we can like run some of the other stuff that was running on CUDA before, leave that running on CUDA, but the background subtraction bit we can run on CPU and pick one that should work better, hopefully. If I've done everything right, yeah. So
Yeah, okay, the background subtractor is much better, but the idea is just first to find the right background subtractor and then port it to CUDA, right? Okay.
Yes, yeah, exactly. And just purely because we've never had Vibe, or we've never, I've not tested Vibe, so it's just because we just haven't had it. So, yeah. So, anyway, so that's kind of it's kind of the main bits that I wanted to demo. Really, is I kind of just wanted to show that we are making progress on the ROS2 version of the application, and there are still some issues, as you can imagine, but I think it's making good progress, really. And considering we started this maybe a month and a half ago, and I also wanted to just show that it's not difficult to run these things as containers, and the instructions, if anyone can give it a go. I mean, if you want me to demo, I can demo it running on a Windows environment, but it's the instructions are there. If you just follow the instructions, you should be able to get the container up and running and see how it works. And I know there isn't a manual that kind of explains all the configuration and all that sort of stuff, but hopefully we'll work on that and get that as out at some point as well. But yeah, that's kind of all I wanted to demo, really.
Perfect. Thank you, Mike.
Okay. Right, let me just see if I can.
I mean, for me, it's incredible that in such short period of time, you not only snapped it what ROS2 needs, and you also showed us that you already have 12. I counted 12 or so nodes already talking to each other.
Yeah, there are a few, and it's not.
impressive.
It's actually, and I know there's lots of stuff that I've done wrong and that is not right and that can be made better and and all that sort of stuff. I completely get that. But I also the point to get across as well is it's worth just giving it a go and trying and experiment. And stuff. It is the containers are there, and if you basically screw up anything that's inside a container, all you do is you just exit out and load it again, and you're back from where you were. So it's there's nothing that you can't really. Yeah, so it's just to try and if there's any kind of sort of barrier to explore this stuff and mess about with, then maybe if there's anything specific that anybody wants to see, then maybe we can just put together a video that is more specific to what is required. Like if people are worried about running containers and they're not sure how to run them or get them up and running, then maybe that's something we can document a bit better or put together a video. And because the ultimate goal is to ensure that everyone can run this stuff and interact with it, and we can then drive improvement and make it better and so forth and so on. But we need that interaction really.
Mhm.
So if there's anything that's preventing anyone from interacting with any of this stuff, then please just let us know and we'll try and make it better. And now I'll be quiet. Thank you very much for your time, guys.
Thanks, Mike, for presenting us. Great work.
Very good. Very good.
Perfect.
Yeah.
Hey, one question I have. Ido, you mentioned before a kind of a looping that Mike has implemented that would not be necessary with ROS2. Can you either explain if it's simple, or if it's complicated, then maybe you should meet with Mike and
Yeah. So I already shared, Mike, under Hangout, I shared with you 2 videos. One that speaks, it's by eProsima, about the fast DDS protocol and its real-time aspect. So that would be a good presentation to see and understand kind of under the hood of ROS2, because ROS2 Humble, the transport protocol is fast DDS by eProsima. That's what will make it real-time. And then I shared another link with you. It's called the shape demo by eProsima. And here you can see how they can subscribe with real-time. You can subscribe with history data, and you don't need to change the publisher at all. It's really up to the subscriber. Now, there are more even advanced topics, how to subscribe to a data that is stored and not real-time data, like a recorded data. So you can subscribe also with like a time span. And if the data is available, you will start getting a playback. So there is a lot of features on that transport protocol.
Thanks.
Yeah.
I mean, I know I've not scratched. I know I've barely scratched the surface with this stuff. And I just, I also just, it's just important for others to also see that it's actually quite easy to interact and to develop on, and we can add those additional features and things as we go along.
Yeah, exactly. Like you did great, like breaking everything to its own node components. That's perfect. And now we can stabilize it, improving on it, and eventually put it out there and improve the reliability and performance of it. Right? That's the idea.
Yeah.
So excellent. Yeah. Like you did exactly what how we're supposed to develop robots. Like really.
Yes,
You're following a great guideline.
Thanks.
Yeah.
Yeah, he had good guidance from you too, so that has to be said.
Not much, honestly. Like it's all
you
Mike.
gave the right hints, let's say.
I'm supporting, yeah.
Hey, by the way,
Well done,
I
Mike.
have a
Really
question
well.
to you
Yeah.
again. Sorry?
No. Go ahead.
Last time we were talking about the background subtractor as part of the preprocessor on the Pi, when the stream comes in from the camera.
Yes. So it's something that I'm entertaining the idea with Christian. Okay. I suspect we'll get them in the future, but not for the alpha version. Okay. Right now, I'm actually having my telescope. The camera is connected to the telescope. There is a Raspberry Pi there, and I run the Indy driver. I'm getting about 4 frames per second right now on the full frame. I want to get on the 19 and make sure the driver works as it should. And then I will wrap it in the ROS2 node and deliver it to Mike. Okay. If I can get the camera out, once the adapter is in good shape and I can seal it and put it out, that's the next big thing that I will do. So we can start getting like this camera, like video feeds and all of that. And I have about 16 terabyte here, so I can store quite a lot.
My question was more focused on the performance of the Pi. Would the Pi at all be able to run a background subtractor?
I suspect yes. It depends which kind. But right now,
it's only CPU.
Yeah, I know. That's fine. There are ways to do that I think that should be good, but I still don't have knowledge about again the QHY driver. That's what I'm trying to get to right now. I want to make sure that it's working and the right frame per second, right? So I can wrap it in ROS2 and deliver it. That's what I'm focused on. Okay, like wrapping it inside ROS2. Once I do that, then I will move to the next step. Like I don't look at the.
No, it's basically Christian's part, but yeah, Christian doesn't hear you. Mike, from your experience, actually, if we use something like a background subtractor during the pre-processing, that means actually that we try to reduce the data stream so that the load on the data stream is reduced. Let's say everything is black and only the events are to be seen in a 64 by 64 pixel view, for example.
Yeah, so my view.
Okay.
Yeah, so my view of that is you still have to process the entire frame, and yes. I don't know if that is gonna make a difference off the top. I don't know. I don't know. I just don't know, because you're still gonna have to process the entire frame, even although most of it's black. You would. Yeah, I just honestly don't know. If it would make a difference or not. I would like to think it would, but I don't know. That's just
what exactly, Richard, you're trying to ask?
I was just how you say fired by the idea of using a background subtractor during the pre-processing to use it as a data stream reduction. That data rate reduction.
Well, if it's used, it's used exactly for that, but for the purpose to improve performance, right?
Yeah. On another device, not on the.
Yeah. So again, it's an idea to improve performance before the full frame is getting into the neural network, right? And that's something we will do after we have the neural network working, right? Like we don't need to improve performance on something that doesn't exist yet, right?
Yeah, we have in this case we have three areas. Let's say the first area is the preprocessor. There's already on the Pi something that Christian wants to implement to preprocess.
Yeah, and right now you have a preprocessor that does nothing.
Yes.
Right?
Yes. Yeah, it's just the raw stream from the camera, right?
Yeah.
And then we have
later on it will be a smaller frame that you will get. right?
When you say a smaller frame, you mean you just crop it in a square?
If you're doing background subtraction, right, I'll only send what has been moved, right?
Yeah, but in full frame. So let's say everything is black and only the moving parts are to be seen. Is it that way?
So I don't.
Yeah, go ahead, Mike.
No, I was just going to say. I'm really woolly on the notion of doing a pre-processing and then like doing two sets of background subtraction, like one which is pre-processed and one which is then processed. You know what I mean? I don't really know. So like in my view, yeah. So I don't quite understand that. Yeah, I just don't get it. So I would probably be inclined to say, rather like I would say I wouldn't do that. I would say I wouldn't do that. I would say I would just do one, optimize the background subtractor for a specific bit of hardware, and if it's the Nano, then like make it run on CUDA and leverage the heck out of that sort of thing, and I think you'd get better throughput.
I think we are different. We are speaking very different, okay? Because the background subtraction that we are doing, we're doing it on the photon electric. We're doing something different.
Yeah, I don't get that.
Yes, so that's what when we speak about pre-processing of that, that's what we are speaking of. We are not speaking about the image. We're speaking about before the image. Before we are constructing the image, we are working with raw data of like photoelectron counts from each sensor in the CMOS.
Isn't that just are you guys talking about the stuff that basically we just take for granted that a camera produces, like a frame?
So, yes.
More. It's denoising, it's cooling, it's reducing.
But it's before. Yeah, it's
the quantum effects.
Yeah, I still I still don't have the data structure of how it looks. Okay, and the normal drivers gives you an image, give you a frame that's like an image. But there is a way to get the data before that, before the image is being constructed by the driver. So there is even a lower level that we want to go to eventually.
Yeah. So and are you saying that needs to run on a Pi? So
yeah, that will be no. I mean we can run it everywhere. Again, it's going to be eventually like a ROS2 kind of node, right? That will do that for the camera. If you think about it, it's the same way. I started getting to ham radio, but it's the same way that you can reduce your like a squelch in radio that you don't hear all the time when you're listening to something. So that's what we can try to do, because in the end of the day. Yeah, in the end of the day, it's frequency and it's a wave, right? It doesn't matter if it's photoelectrons or radio signals. So we are trying to take that approach.
Isn't that kind of counteracting the argument of trying to track the ISS, which is quite small?
No, because we will still be able to see that. There will be a distortion in the wave, right? I need
yeah,
to.
I don't know. Yeah, it's okay, mate. I don't get it. Yeah, so when I think it's. I'll just leave it at that.
Think about it.
I don't get it.
So think about it. If you have like a straight line, right, like a wavy line that describes the visible spectrum, okay. Now, if the skies are, let's say at night is the easiest. So because it's all black, the lines are going to be very much in the bottom. And if the ISS is visible and it's like, reflecting from the sun, you're going to see that wave spike, right?
A histogram, yes.
And that spike is what we will do. That's the anomaly that we are going to try to detect. So what we are doing, what we want to do is, if we record everything, like, in history and average it out, we are going to normalize the background. And once the background is normalized, then you can detect anomalies.
It's actually something that cameras and their drivers always do, because they're always adjusted to the hardware.
Yeah, but we are just going to increase it.
The good
I guess
thing
we
is
don't see
that you have access to the driver and you can tweak it yourself. So we can tweak it. We can take that from the camera, that kind of the quality we want.
Yeah, exactly.
It's not
So
standard.
I don't think that's necessarily going to have a performance impact on the stuff that I'm working with currently, because it's still going to have to process the whole frame.
Yes. Yeah. You still need to do everything.
Yeah.
You will just get probably less data in the future.
And also if we're talking about randomly resizing the frame, like, you know, changing the shape of the frame, then because just wait. So if you randomly like change the shape of the frame, then that's going to have other implications of when you apply the mask, they have to be the same size, and you know, so we'll have to potentially resize the mask to the frame on every, you know, all those sorts of things.
No, the frame will stay the same.
Not exactly. No, yes and no. Okay. Mask needs to be simple because that's something that the user does. Okay. But the mask needs to be like an input to the neural network once we get into the neural network of things. Okay? And then the neural network needs to take, if you create like a 16 tiles or 1024 tiles from the frame, you need to create those tiles per the mask as well, right? If you think about the neural network pipelines. Right? So you receive the full frame, you need to break it out to like 1024 tiles, and then neural network works in parallel on everything, right? On each one does background subtraction, tracking, and all of that, condense it into one, spit it out, right? And that's probably will be, Mike, the next step for you. You know, after you complete like this round, how we map it. You know, once you complete like it's working on GPU, it's working on CPU, it will be how can I now do the processing pipeline.
Yeah, so that is definitely one thing I'm interested in and I need to explore, because one thing I have realized is that so a lot of the messages that are going across my nodes or my topics are my message types, and I need to kind of revert to stuff that's standardized. So I need to, but in order to do that, I need to know what ROS packages are out there and how they can help and how they can, you know, so essentially which bits can I plug in from stuff that's already been developed versus me developing it. And so that's not something that happens overnight, you know what I mean? Because you need to understand the package and the messages and the pipelines and all these sorts of things. So and that's why I've always said the bit that I'm working on now will eventually be thrown away, because it will be replaced by something like that. But in order to get to that understanding, I had to go through the first stage, which is develop an application in it, you know.
Absolutely.
No, you're doing excellent. You're doing like wonderful, honestly.
Yeah, well, we try, but yeah. So
you know, you have some skepticism in you, but I think eventually you will learn that you can surprise yourself. So, you know.
Yeah, I maybe I gotta kind of. I got to see a picture first and understand how it works before it makes sense to me. So some of the stuff doesn't at the moment, but I'm sure I'll get there hopefully.
Richard, are we still recording?
Yeah, I'm still recording. Yes, you want to show us something?
Oh, okay. I can show you Nick's. Do you want to see Nick's?
Nick's? Oh yeah, is it your parrot?
No, Nick's. It's my operating system. Yeah.
Show us.
When we're done recording, I have a question. Somewhat related to the camera.
I can stop recording if you want to. Okay. No one.
Yeah.
Okay.
I'd go ahead.
Stopped.
So